because I've learned that don't record from your machine because it just crushes it. Anyway, Joe, the floor is yours, and we look forward to it. Thank you.
Cool. So thanks for the introduction, James. I'm Joe from Grafana Labs, and we're going to be talking about observability. Observability is a very important part of your kind of cloud or your Kubernetes kind of life. You have to be able to see the things that you develop. You have to be able to see how they're acting and what they're doing so you can make sure that they're working. And that's an area that Grafana kind of excels in. So today we're going to look at a number of open source projects that Grafana maintains, Grafana itself, Prometheus, and Loki. And we'll probably talk a little bit about Jaeger, but we'll do a little bit less there. Let's see, I think I can share my screen somehow. Doink.
Should be able to.
Yeah.
There we go.
Cool. And then I was also kind of hoping, or at least thought it would be nice if this could be, or could be kind of more of a conversational kind of experience. If anyone has any ideas or thoughts, a lot of you have probably worked with some of these technologies before. And if you have, I would definitely encourage you to, I don't want to say interrupt, but is there like a way to raise your hand? Isn't that something in Zoom, like a hand raise thing?
You can also post something in chat, and I'll just keep an eye on that. So
Okay.
I'll make sure to interrupt you.
Okay, cool.
But yeah, we definitely want to keep this conversational. If you guys have a question, if you don't feel comfortable speaking up, just go ahead and post it in the chat.
Cool. So this presentation will be based on this repo, which might be a good thing to post in chat. If I could find it. Oh, there we go. Maybe? There it is. Man, I don't use Zoom much. Apologies.
No, you're fine. Go ahead.
Sure. So this repo just has the steps I'm going to be following. It has some YAML and some other like other information to deploy to Kubernetes. And it also has kind of my notes in there too. So I'm going to be working through these notes, and I'm going to be using the instructions in this README to do everything I do in this presentation. So you're welcome to mess with some of this as I do it. You are welcome to take this later and do anything you want with it. If you learn anything or you enjoy anything in here, I'm not going to delete this anytime soon, if ever. So this will kind of be here to go back and review some of this if you want to. So observability is, just the ability to kind of see the applications that you're managing. This is extremely important, of course. A lot of us who work in the SRE, DevOps infrastructure space have these things called like SLOs or SLAs, and they're kind of targets for our applications to behave a certain way, like 99% of all queries return in a certain amount of time, for instance. Without observability, without the ability to see some of this, it's impossible to even begin understanding how your applications are behaving or if you're meeting the needs of your customers. So observability is a critical piece to building any kind of application, not just Kubernetes, not just cloud, but anything, I would think. When I built Kubernetes clusters years and years ago for my previous company, the final piece I put together where I felt confident to move this to production was my observability stack. And at the time it was Prometheus and Grafana. And I have been using them ever since. I absolutely love those two pieces of software. I think they're fantastic. They work perfectly together, and you can do a whole lot with them. Today we're going to be looking at, to real quick talk about three pillars. This comes up a lot. I don't know where this came from, but they talk about the three pillars of observability: logs, metrics, and tracing. We'll look at definitely logs and metrics today. We're going to look at two applications that do an amazing job of managing and providing your logs and metrics. Tracing, if we have time or people want to stay on a little late, I don't mind showing tracing as well. I personally have done a bunch. I manage our internal distributed tracing infrastructure. I personally have a passion there and love tracing, but it is kind of the three, the one that fewer people use, definitely like a final step maybe in an observability story. Logs and metrics come quick and are necessary. Tracing is also an extremely cool and very important way to see your applications, but is not often as important, I would think. Definitely wouldn't be the first thing I would spend a bunch of resources on. So Kubernetes, of course, we're going to definitely deploy to Kubernetes. I'm going to use K3D. K3D is one of many different ways to locally develop or work with Kubernetes. Kind is very popular. I've not really used it, but I think, oh, actually, let me delete that then, because I've clearly already done this.
Yeah, I'm a big proponent of Kind. I was using Minikube there for a while, but Minikube had its drawbacks of not being able to do multi-node clusters. And then I discovered Kind, and it helps a lot from that perspective.
Cool.
Who manages K3D?
Rancher.
Rancher? Oh, okay. We had
K3D
them.
is K3S in Docker.
Gotcha. Okay. We've had them come and talk to us about K3S, so I didn't know. It's good. Thank you.
Cool. Yeah. Kind, I think, is the current blessed Kubernetes way to do this. So a lot of people use Kind. I probably would also use Kind, except I've been using K3D for about a year now, and I haven't figured out Kind yet. I imagine it's as easy and straightforward. But anyways, so just with that one line, we created a Kubernetes cluster, or it's a single node cluster. And with this export, we're setting our kube config value. So now I can interact with it, and I'll do a git pods, and I have nothing. I can do like a git namespace. These are just shortcuts I use locally to retrieve some of this. This is actually like kubectl git ns namespace.
What'd you say?
Kubectl, that's how you pronounce it. If you know that, James.
We'll save that for the beers and the recordings turned off. Anyway, sorry, Joe. Go ahead.
No worries. So we now have a local cluster, and we're going to start deploying some applications to this cluster to do observability, to do what we've been talking about here. We're going to start with Grafana, and I wanted to show a few different ways to do this. So there's a million ways to deploy to Kubernetes. Those of you who have managed Kubernetes clusters probably have a mix of some standards plus some scripting that helps you out. And every kind of, I think, develops their own process to do this. And we're going to show three different ways. I'm going to use just some YAML files, which I'm going to deploy directly. In fact, let's go ahead and do that. So this is going to deploy Grafana along with some configuration. You can use Helm as a very popular option. We'll use Helm for Loki. That is the log application we'll be using in a little bit. Also, you can use, what is the third thing? We're going to use an operator. So we're going to use the Prometheus operator to deploy Prometheus. And an operator is an interesting pattern as well, and we'll get to that when we get there. But anyway, so I just deployed something at least. And if I do a git pods, I can see I have Grafana running, so something worked. I can also see my config maps, and I have a handful of configuration options here. Grafana is I would say the visualization platform for all of our observability, or everything we're going to look at tonight. Grafana is completely open source, as all of the applications we'll look at tonight. This is free to use. Again, at my previous job, I set it up, a Grafana Prometheus stack, and we never paid a dime for it. We spent an enormous amount of money to keep these applications, or to build and promote these applications. And then the idea is, of course, a very small percentage of this enormous user base will need professional services or managed versions of this. So we have managed Grafana and Loki and Prometheus for people who are a very, very large scale. If you are running a 30, 40, even 100 node cluster, you can, with 1,000 pods or something, you can get away with doing this yourself if you put some time into it. And if you don't feel like that, you can pay us. So this is Grafana. Grafana is the visualization layer for everything we're going to look at. It's very feature rich. There's an enormous number of data sources. Grafana's primary philosophy is to be a big tent kind of application. So we include anything that has enough community support to make it worthwhile. We don't have any involvement with Influx or OpenTSDB, but we have, of course, data sources for those. We do have a managed graphite and Prometheus type. We have no involvement really with Elasticsearch, but people like Elasticsearch for logs, so we support that. We have minimal Jaeger and Zipkin support, or involvement, but we support tracing. And then you can do MySQL, some other databases, even some of people we consider competitors, Datadog, Splunk, these guys, we have visualizations for these as well. So the goal of Grafana is generally to include as much as possible. If you want to visualize some kind of information from some kind of data source, there's probably a supported Grafana plugin, a native Grafana plugin, or if not, somebody has probably written one. Grafana is a very popular way to view this kind of information. Grafana also supports like alerting. We're not going to get into all of that tonight, but alerting is common, and you can do notifications to Slack. You can do notifications to popular managed products like PagerDuty or some of these other things. So there's a lot of ways to do alerts and other things through Grafana as well. But we just deployed Grafana, and I wanted to point out that we deployed it in the way that I enjoy the most, or I think is the best way to deploy Grafana, at least for the scales I've used it at, which is with a static set of provisioning. So everything that controls what Grafana is right now, if I look here, I have 3 data sources. I have a Loki data source, a Prometheus data source, and this fake one, test data. I also have a dashboard somewhere. So this is an example dashboard, and it's using that fake test data source. All of this stuff is defined through Kubernetes config maps. There is no other source of truth here. I didn't have to stand up a MySQL instance or a Postgres or any other kind of backing data source. This is all in these 3 config maps or 4 config maps down here. And through those, I'm able to deploy dashboards, data sources, alerts, all of these typical pieces. And that's my personal favorite way to provision Kubernetes. You kind of make some kind of package. It has all of your dashboards. It has all of your information. And then you can even, of course, you can have that in Git. You can do pull requests. You can see, you're changing a query in a dashboard, or you're adjusting an alert configuration or something. You can merge that to master and then deploy. Grafana also supports, it does support backends, persistent backends like MySQL. So, and some people really enjoy using it in that manner. Personally, I definitely prefer this though. So to quickly look at these, so these are the 4 config maps that are kind of like driving the this whole dashboard setup here. If I just kind of dump one real fast, let me do describe. Let's do our data sources. So I can see that I just have a config map. I imagine a lot of people here are Kubernetes at least somewhat aware. And this is a config map where we're just making these files. So in the container now, there's a file called loki.yaml, and this is the contents. And this is defining my Loki data source. And this is Prometheus, and this is defining my Prometheus data source. If I were to do a KC edit of these things and change them, roll my pod, then it would take the new values, and I could very easily kind of change and update the data source itself. I would never edit a data source like this except in maybe some kind of extreme or terrible situation. I would definitely always do it through some managed process, but I just want to show that this is a possibility.
How's that looking for everyone else? I mean, it looks fine for me from that perspective, but I just want to make sure that everyone else can see the screen and what he's doing from the command line perspective.
Is that a little small? Should I?
No, it looks fine for me. I just wanted to ask, just in case no one else wanted to speak up, but it looks fine. No takers. I think you're good. Go ahead, Joe.
Cool. So this is Grafana itself. I could spend an entire session doing nothing but looking at Grafana options, so we won't. But there's a million ways to visualize data, graphs, bar things, this gauge up here, tables. This is Grafana 7, which was just released 2 weeks, I think, ago, 3 weeks ago, 2 weeks, 3 weeks ago. It was released at Grafana Con online. We did an online conference instead of our conference in Amsterdam, which I was really looking forward to. But we did an online conference instead. And they released Grafana 7, and this is a fantastic, and I don't know, everybody's pretty excited about it. This edit panel over here is far better than it used to be. They've done a lot of good work here. But anyways, so a lot of different visualization options. Additionally, it has really rich plugin support. So there are options to show world maps. You can like do a world map and like geolocate on it. There's an enormous number of visualizations available through plugins that you can grab online, and we won't get into all that. I mentioned Grafana Online. Grafana Online is what they called it. It's always hard to say. This link I just put in chat is just a list of the different presentations there if you have interest in any of those. I'm also going to, do I have the Loki one that I wanted to share? Maybe I don't have it. On that list, there's one that is the Nissan Leaf demonstration. I highly recommend that for anyone. It uses Grafana in probably the most extreme ways you can. A very, very cool use of Grafana to show live metrics off a Nissan Leaf, like battery usage and power and things I didn't understand so well. But it was an amazing application of Loki, Grafana, and some of these things. So I highly recommend the Nissan Leaf talk. But anyways, this is Grafana. Grafana is cool, but it is kind of useless unless we actually have data. We need something. We need something to see with Grafana. This right here is just test data. This is nothing. In fact, I think if I refresh it, it will make different test data. Yeah, so it suddenly looks different. So this is just fake random data that's useful for, setting up a dashboard or do something silly, not necessarily useful for, monitoring anything. So we need some data, and we're going to look at Prometheus and Loki in order to create logs through Prometheus. Logs. Loki is going to aggregate our logs and provide our logs to Grafana, and then Prometheus is going to aggregate metrics and provide metrics to Grafana. Grafana itself has no ability to store data. It doesn't do that. It's all visualization, and it queries different backends. So let's see here. Loki, we're going to do a Helm install of Loki. So I used Helm at my previous job, and I really like Helm, but I would have never done this. I hate this. I'm going to do it because it's the easiest way to get Loki going. But the reason I didn't like this is if I did this, I never really understood what I was doing, and that kind of always drove me crazy. I was installing a chart someone else made, and it did not always sit well with me. So what I always did was take somebody else's chart, take it apart, understood the pieces, and kind of rebuilt the chart myself. So Helm charts are very cool. They're a very quick way to install a lot of things. My personal preference is to really understand what the chart is installing and make sure I need all the pieces. Helm charts that you find online are extremely complicated because they have every configurable option ever is exposed. You can often get those down to maybe the 10 that you actually care about and have a much more concise Helm chart that is good for you. But a lot of people do it this way, and there's nothing wrong with doing it this way. This is a very fast way to get a software running on your Kubernetes cluster.
Joe, I'm in the same boat as you. I like to decompose them or make them myself. But from getting a developer up and running and onboarded to a new application, it's much faster for them, especially if they don't care.
Yeah, that's fair. So we did a quick Helm install of Loki, and I'm running two things here, Loki 0 and Loki PromTail, 2 pods. I'm also going to very quickly install my Prometheus stuff. We will get into, we will get into what this is doing in a second. The reason I'm installing it now is because if I install it now, I can let it collect some metrics while we're talking about Loki, and then we'll have a little bit of history to actually look at. If I install it and immediately go attempt to use it, it'll only have like the last 30 seconds or a couple minutes of metrics, which is not as interesting. So we've installed, at this point, both Prometheus and Loki. We're going to just talk about Loki for a little bit, though. So Loki is log aggregation and querying. This piece here, this PromTail guy, is the equivalent of, let's say, FluentD. I think a lot of people are familiar with FluentD for log offloading. FluentBit is also popular. And then I think there's some other ones, but I don't really know them very well. So this PromTail piece is actually used for log offloading. It aggregates the logs. It just slurps the logs up and sends them to Loki. Loki's job is then to store the logs and make them queryable for Grafana. PromTail supports a lot of cool features. I can probably get a config map real fast. Although I'm not sure what, oops, how do you describe CM, Loki, PromTail? Gotta type all the stuff. The config map is, oh man, it's large and complicated apparently. It is built off the Prometheus config map. So PromTail supports, and all of Loki is kind of built around some of the same ideas as Prometheus, and it supports the same Kubernetes service discovery that Prometheus does. So if you are familiar with Prometheus and the Prometheus config, this would look very familiar to you. But PromTail supports a lot of cool features. It can extract labels. We're going to talk about labels in a second from your logs. It can also do cool metrics, like it can just look for certain keywords like the word error, for instance, or warning, or critical, or panic, or a lot of these like common words we want to see from our applications. And it can metric those logs or those kind of words, which you can then use to get a feel for how your applications are behaving or even alert on. But if we go look at actually what Loki is doing, let's do, this is called a label. So if I start typing a little bit here, or if I don't type at all, perhaps, I can see a list of these guys here. And these are labels. And this is an important idea in both Loki and Prometheus. They both index labels only. And it's an important design decision about, of Loki that kind of separates it from Elasticsearch. Elasticsearch indexes all of your text, which can be very important and has very good use cases and certainly is a very successful way to store text. But for some kind of use cases, it's just overkill. It's not necessary. And you can get away with something simpler that costs less to operate. And that's what Loki is, kind of the niche Loki is attempting to fill. An open source log aggregation utility that purposefully indexes only a piece, only some things you might need to query your data instead of a full text index. So if I look at, I'm going to do job, because job is a very easy way to, job equals job name, yeah, no, sure, that thing. Oh, let's just do this. Oh, it just did that, didn't it? Container name, no, job name. Why is that the only one available? Sure. So these are the traffic. I am kind of surprised that that's the only one available. Shouldn't I be seeing other ones? Probably, right? Right, guys? Should I be seeing other things here?
Did we get the application? Did we get your test application running?
Yeah.
Or are you trying to pull the logs for Loki?
Right. I thought there it is. Okay. It wasn't showing me in the autocomplete, I guess. Job. It's really wanting me to do job name. But job equals, all right. So this is a combination of the namespace and the actual thing that's running. So I can grab like Grafana logs here, for instance. So this is just like the last few minutes of Grafana logs. And whatever. We can kind of take a look at these. What Loki is great at doing, kind of one of the things it was built to do, is very easily grep and very quickly grep your logs. So this is, in this case, looking for this word executing. It's a substring search, as you'd probably expect. It's kind of a pipe-based syntax. I'm saying look for these log streams, and then I'm saying filter on this keyword executing. And then it kind of allows me to quickly home in and figure out what my applications are doing. Loki is, in our cluster, a highly distributed application, and it can grep, I think our record is something like 60 gigs a second, so it can hit extremely high, read rates. The kind of insight here is that your most log applications are writing 99% of the time, right? It's all write heavy. So we're purposely not spending as much on the write. We're purposely not indexing everything. Reads are rare, so we can spend tons of resources on a read because a query is, compared to the writes, significantly more rare. So we're spending way more resources on the read side of it in order to build like a cheaper system, essentially, a system that's easier to operate and costs less money. So anyways, I found the executing keyword here, and maybe I'm probably looking for more like, I don't even know if I'll find anything, but like we could look for something like error. Oops. Yeah, we found some errors, sure. Error sending batch, we'll retry. This is probably from PromTail. So when Loki was first starting up, PromTail would start it up faster, and PromTail was attempting to send to Loki and failing. It was kind of buffering these log lines locally, and so it logged these error messages while it was buffering them. And then once Loki was started up, it was able to send all those. So we can see some errors here. Loki is also really cool about doing metrics off your logs. So I can look at, we'll unpack this, we'll unpack this query in a second, but what I'm seeing here is actually the rate at which certain log lines are occurring. So I can see the rate at which the word error is appearing in my logs, and this rate is calculated over the past, is like a 1 minute rolling interval. So that's what that 1M means, 1 minute. It's actually a per second rate. So I was logging about I can't see that very well because of Zoom, but 0.18. I was logging around 0.18, 0.2 word errors per second at that moment. And you kind of see how over time we can use Loki to query metrics out of your logs, which is really neat. Additionally, new features are coming out that would actually allow you to extract key or actual values out of your logs. Like say you have an Nginx log, and the Nginx log contains a latency number in the log line. Extensions are being added to Loki to actually pull that number out and use it to calculate, say, like P99 or P50 on a certain endpoint. Very cool stuff. That's really neat stuff. The Loki team has spent a lot of time working on that lately. So this language here is a Prometheus-like language. We'll look at Prometheus a little bit more in a second. But this rate is a Prometheus function. I'm saying the rate at which this thing occurs. And this 1M, like I said, is a range over which to calculate it. It's looking back over the past minute. So for every second over the past minute, how many times did this particular thing occur? How many times did this error occur? I don't know if Loki supports increase or not. I should check. It does not. Increase is another common one that Prometheus supports. We'll look at that in a second, but clearly Loki doesn't. Loki also does, let's see. You can also do like regex, and I'm not going to be able to put together a sane regex probably, but you could do like this, something like that. So things that, log mode, right? You got to go over here to log thing. So you can do a regex search. This is anything that has the word error somewhere in it, I guess, which is a silly regex to search for, but it's possible. And it's kind of like highlighting the pieces of the log line that met that grep, that filter. Also, and I'll go ahead and go over, this is our ops tools cluster. I'll show a little bit of Grafana's internal stuff. You can also, and this is pretty neat, this is actually the Loki dashboard itself that we use to manage our internal Loki cluster. And ops tools, PromTail, no, tempo div. So this guy right here, one of the neat features of Grafana is being able to build dashboards that include logs along with metrics. So yikes, something bad has happened. Oh, these are deployments. So this is a deployment. We're seeing kind of like an increase in logs here. I kind of see these annotations are pretty neat. We can see metrics change at that time. And we can kind of zoom in. So, something weird happened here. Let me kind of jump in here. I can see the exact logs that line up with the metrics that were occurring at that time, and hopefully come to some understanding of why everything's blowing up, which is normally the goal as quickly as possible. So you can stop the blowing up. So we talked a little bit about Loki's syntax. Loki's based on this label kind of idea. We talked a little bit about you can take these labels, you can use the labels to identify like an application or a different log stream, and then you use these grep filters on the other end. Excuse me. use these greps on the other end to kind of reduce your filt logs to kind of home in on what you're looking for. Loki has some neat integrations as well. This dashboard's one. This application is pretty cool too. So this is something we run internally. This is a open source application as well. If I can get Chrome to work. Grafana. Kubernetes diff logger. This thing right here is mostly maintained by me. And it watches for changes in Kubernetes objects, like a deployment or a config map or a service, and then it logs a single log line that occurred that says that happened. Oh, man, Zoom really doesn't like me clicking at the top of the screen here. A single log line that indicates that happened. We can then use Grafana to look for those log lines and add an annotation to our graph. So this right here is just showing, oh, there's a fun, come on, Ed. Ed deployed a image with a cuss word in it. Let me be a little bit more PG here and jump. Nope, still, come on, Ed. There you go, buddy. Let's go back to this deployment over here. I don't know what the policy is around here, but we'll skip Ed's shenanigans.
We'll stick the CNCF on him.
There you go. So this right here is showing us that the container image changed, and it's showing us the image name went from this Loki K25B whatever to Loki instrument dash reprocessor whatever. So the team was deploying some custom images to maybe suss out a bug or determine, maybe trying to figure out what was going on. Special deployments. In fact, all of the deployments this afternoon suggest that's exactly what was happening.
So instead of having to rely on the Kubernetes logs, the audit logs for that, because that event does get logged, this just allows teams to be able to see that at an individual like namespace level.
Yep.
Okay.
So we have that as well. It's called event router locally is what we call it.
Okay.
Default. No. Oops. Let's do this. Yeah, there it is. Oh man, the autocomplete in Grafana is fantastic and never breaks. So this is the event router logs. We tried to do what I just showed you with the event router logs, and we really struggled to find some clear single line events that told us exactly what was happening and that a new deployment occurred or a change to a deployment occurred, and this was the change. And that's what we really struggled to suss out. What we built then was a thing that just logged in the simplest, most straightforward way, the exact change that occurred to the Kubernetes object. And I would love to show you what those logs look like, but I know it's full of cuss words now because of Ed. So we're not going to search for those. So this is a really cool utility. If you are into Kubernetes, if you use Grafana, even if you don't, it can be useful to see what has changed in your infrastructure using this utility. And to do a quick promotion of open source, please get involved, submit issues, even just writing up an issue. If you find something and write it up, changes to docs, pull requests, any kind of update or just community involvement we support and want to encourage. So if you find yourself using utilities like this, please get involved. Please talk to us. We are big on building the open source community to help build tools for all of us to use. But anyways, so this annotation trick is really neat. I mean, we love this here. We can see exactly what change occurred on a graph, and we can see other changes that occurred in real time along with that. It really helps us home in and understand how our deployments are impacting our metrics. Yeah. Oh, one other trick. This is kind of neat too. And another kind of Kubernetes, another Grafana Loki integration that's really slick. If I do, let's say, I'm going to look at, I'll go with tempo dev. No. Let me do ops, query front end, Cortex ops. Sure, Cortex ops. Cortex is our Prometheus backing permanent long-term storage solution. It's also an open source application, also visible. All of the code that we're running is visible externally. We have no tricks. But we're going to look at this here, the query front end, question mark. Here, this guy. So another cool integration between Loki and Grafana is a way to build links directly out of your log messages. So in this case, we're going to link over here to a trace. And so I can get a log message here. Maybe I see one errored, or maybe I can find one that has a really long timeout, something that we don't like. I could search for 500s. I could do some kind of Loki query here. And then I can go straight to a Jaeger trace over here that shows me, you know, I can go dig in this exact query, maybe understand why it took so long or why it failed. And it gives me a much better understanding. I can really pinpoint an exact query and what's going on. I said we wouldn't talk about tracing a whole lot. I personally love tracing. I think it's really neat. I'm most involved in tracing at Grafana. But like I said, it's kind of often like the third one that people adopt. If you see this, you will maybe appreciate how powerful this is. But it is one of the more difficult ones to get going of the 3 pillars to kind of invest in, I would say. But anyways, so that's mostly Loki. It is an extremely powerful tool. We use it every day. An important kind of rule at Grafana is we dog food everything we write. So we use Loki, Prometheus, Cortex, Grafana. We use all of our own tools to monitor our own infrastructure every day, so we can improve it and we can make sure we know that we're providing something, you know, a utility that's actually useful. So that was mostly Loki. I could take a quick stop here if anybody wants to talk about that before we go to Prometheus. Is there any questions on that or thoughts or general grumbling or go use the bathroom or whatever?
Is anybody using Loki?
That's a good question.
I know I'm using Grafana, and I know I'm going to call Matt out. He's one of my coworkers. I'm pretty sure we're using Grafana for one of our clients as well.
I think I've seen Grafana before on my cluster when I was messing around. I haven't really used it a whole lot, so I'm kind of just taking it all in and writing down notes on things that I want to install here when I get back to it.
Cool. Cool. Well, let's move on to Prometheus then. Prometheus is a fantastic utility. Prometheus is kind of what got me super passionate about being like the SRE role. Just the amount of observability, the amount of vision it gave you on your cluster, on your applications, the ease of like creating your own custom metrics and not just watching your cluster was just fantastic. I think I'm going to turn the lights on actually. It's getting dark in here. One sec.
Is anybody using Prometheus? I know we are, and Matt's just sitting there. He's probably taking all of this in. I know we're using that at several clients as well.
I'm using it through GitLab.
Yeah, GitLab's they've got some really nice integrations with open source CNCF tools.
Cool. So Prometheus is the final guy we're going to look at. Prometheus is just a key element of the whole CNCF landscape, observability universe, Kubernetes world. A common knowledge is that Kubernetes kind of came from Borg. Borg was the internal Google orchestration engine that inspired Kubernetes, basically. So Kubernetes kind of being the open source version of that. Prometheus is the open source version of Borgmon, which was their internal metricing and observability metrics application. It was developed by SoundCloud in like 2016, I think. And a lot of the original authors work at Grafana now, and we spend an enormous amount of time and money making sure Prometheus maintains kind of like all of the features and things people need. Prometheus is a key element to our world for sure. But Prometheus is, well, let's talk about how we installed it first before we get too much in there. So we used a Kubernetes operator. And I actually don't have much experience with Kubernetes operators. I mainly do things manually. I want to maintain and understand the applications I run, but Prometheus operators are kind of an interesting way to quickly get something up and running. An operator generally is like a pattern in Kubernetes. It often uses advanced features like CRDs or webhooks or other pieces to integrate deeply with Kubernetes. and provides a similar experience to what the actual native controllers provide, or like an ingress controller provides. So like with an ingress controller, you create an ingress object, and then some magic occurs. And if you've built all this, you know how this works. But basically something happens, and suddenly you have ingress to one of your applications. So a operator is similar. We're going to create a Kubernetes object. We're going to create an object like an ingress, or an object like a service, or a pod, or a deployment. And then this operator is going to do the job of making all of the different pieces to make this object exist, kind of. So you interact with Prometheus. If you're using the operator, the Prometheus operator, we're going to interact with it in the same way we would interact with Kubernetes itself. We're going to make Kubernetes native objects. This operator is going to watch for changes in those objects, and then is going to go do other things, like make a Prometheus itself or make a service. So if I do kc get Prometheus, which is not something that would work on a normal Kubernetes cluster, I can see I have an object of type Prometheus called Prometheus, and I can describe it. And I can see it comes out exactly like a pod would. It has the same basic metadata, namespace, labels, annotations. And then down here we have its custom parts, right? Like, okay, it has this thing called a pod monitor selector. Okay, that's nothing native to Kubernetes. That is defined by what is a CRD spec. So we can, an operator often gives you this really nice method, this kind of native way of interacting with, wow, even autocomplete works. That's kind of cool. This kind of Kubernetes native way of interacting with an object, which then will change deployments or do other things, like work on your behalf, basically, to create applications in your cluster. So I could even edit this and save it the way I would do a normal object, and things will figure themselves out. But I'm not going to, because I'd probably break it. So what we have created, let's see, is a object of type Prometheus. And what that did was make this Prometheus instance right here, with this pod. We also made an object of type pod monitor. Get pod monitors. Yep. So we made this thing here, and this is actually monitoring Loki. So let me do a quick describe on it. Oops. Yeah, pod monitors Loki. Cool. And so this kind of includes some information about basically how to find Loki. Excuse me. Yikes. So Prometheus itself has a specific kind of model that is important to understand, which is a scrape model. There's kind of like this push versus pull kind of debate in this world. Prometheus is based on a pull model. Prometheus actually reaches out and makes an HTTP request to your application, and it asks your application its state. It asks for the metrics from your application. I can probably, let me do this real fast. Casey, Prometheus is on, well, let's do Loki. 0, I think this is 80. Let's try. Maybe? Nope. Oh, what is, okay, clearly I don't know what
9001, I think. Are you talking about the Prometheus?
Prometheus, I think, is 9090.
Yeah, okay.
Let me try that. I just want to show you what some example Prometheus metrics look like. They're pretty straightforward. Yeah, let's try 9090, 9090. Sure. Yeah, there we go. So this is metrics in a Prometheus format. And this is a simple HTTP request. I use curl. And I got back text. So this is very easy to understand and work with, which I think is one of the reasons Prometheus has been very successful. It's easy to understand what your application is telling Prometheus. No special tools, no crazy formats, just a simple curl will give you exactly what you need to know. And here we can see a stack of metrics basically coming out of our Prometheus server that Prometheus is consuming to metric itself, basically. So in this case, let's look for something interesting. Sure, nope. Oh, wait, oh, I got the wrong one. There you go. Sure, here's some extra web federation errors, SD file read errors. SD file is the service discovery file. So this is a metric that tells us basically if the service discovery file has failed to be read, I suppose. You'll find in the observability world, people get kind of crazy about this and they want to see and know everything. It's kind of fun. It can be overwhelming though, and kind of understanding maybe which of these metrics to care about is a matter of experience, I would say. I often want to see them all at first, although that's overwhelming and not often necessary. And as you understand applications, you can kind of like hone in on the exact metrics that help you really, know how this application is behaving. Additionally, on Grafana dashboards, this is another way I personally always started. When I had a new application, I'd always come here because somebody would have posted a dashboard for your application almost always if it was popular. And then you can kind of get a start basically on the kinds of metrics that other people have considered important. And it's often a really good base to begin building your dashboards and your information. So I know when I curl this, you see all this and you're thinking that's an enormous amount of information. It is, but it is less than you think it is. There are fewer of these fields on an hour by hour or second by second timeline matter. And the ones you want to watch are often very few. And then you often can, once you find an issue has occurred, start digging in the longer list of metrics to understand what really happened there is a good way to kind of go about like understanding this huge list of metrics. So Prometheus, don't go to places. Prometheus, is this my local one? Let me go to my local one. Exports metrics, we'll go to explore. And I'm going to switch my data source up here. So I was querying Loki. I'm going to query Prometheus now. We're going to look at this. So this is a metric produced by Loki, and it's going to tell me the rate at which this instance of Loki, the one running in my little local thing, is consuming bytes, basically. So not much, unshocking, right? Who would have thought that the thing I'm running in my little local K3D cluster would be consuming no amount of bytes? So it was doing a massive 87 bytes a second right around here. And now we're at, we're spiking at three bytes a second occasionally. So obviously this is nothing, but it shows you the kind of information you can gain about your application. The types of metrics that Prometheus supports are very few. So we saw a huge list, but these all fall into a very small number of types. This is the first type, and honestly, maybe the most important type. This is called a counter. In fact, Grafana is prompting me that you're looking at a counter, user rate. A counter is a value that never goes down. We always add to it. So in this case, this is the total number of bytes that this Loki thing has ever received. By adding this rate function around it, I can then learn, well, the rate at which those are occurring. So counters are very, very common and very, very important kind of metric. In fact, I'd say almost all of our metrics are counters. Another important kind of metric is a histogram, or sorry, a histogram. So this is another thing we always want to know, which is how fast are we responding to queries? Let me unpack this query in a second here. Come on, Zoom. Oh, my bad. I want to come here. So this is going to be the P99. We'll add a P90. These are some of my personal favorites to watch. And we'll add a P50. Oops, I don't want to do that. Go away. I don't know why, but I personally have often kind of gravitated to these 3 percentiles when I look at latency metrics. So what this is showing us is the 99th percentile for this latency, for this endpoint, which means it means that 99% of my queries have come in under 0.005 seconds. And I can see that 90% have come in under this 0.0045 seconds. And then down here, we have the 50th percentile. Half of the queries have come in under this value right here. This is an important way to look at your applications. You'll always have spikes. Your P100 or whatever, your max will always have outliers. And so it's often more interesting to look at values that correlate directly to kind of what you've promised your customers. And what you've promised your customers is often things like an SLA. And your SLA is 99% or 99.9% or 99.99% of all of your queries will come back in 1 second. And so that's what you want to watch. And so that's why we have these like histograms. And that's why we're not looking at max. Average is also another one that sometimes makes sense, but is often influenced by these max values. And so we often care about these kind of things, these histograms. So this particular endpoint is log proto push. This is a gRPC endpoint that is receiving the logs. So the logs are being pushed from PromTail to Loki, and this is metricing how long it's taking Loki to ingest the log line and reply, I got that, everything's fine, essentially. This is complicated. Yeah, this is complicated. We're not going to pretend it's not. Excuse me. In fact, oh, did I? No, I didn't get to see Loki. Let me do this instead. We're going to grep for bucket. There. So this is a histogram of what it looks like to Prometheus. What it is just a stack of counters. Is there one with some actual values here? Here we go. Some more interesting values, perhaps. Maybe. These are kind of interesting. I was looking for one maybe that was actually spread across some values, but I'm not finding any. So what this is saying is that these are actually all counter metrics. You mentioned the counter. It always goes up. This set of buckets is just a bunch of counters. And this is saying that 372 times this endpoint has been called, and 372 times it took less than 100 milliseconds. And then also because it's also 370 times it took less than 1,000, and then 10,000 and 100,000. So this isn't very interesting because what you'd hope to see, or maybe not hope to see, but what you could see is like 5 on this top bucket, and then 20, and then 1,000, and then 10,000. And that kind of gives you information about which buckets your queries are falling in. And then that's what kind of was what you use to build your histogram over here, these kind of values over here. Prometheus is in particular so commonly used and such a powerful thing because of its extremely wide support. So if I do anything, in fact, we used to use C#, so I'm a fan of .NET. I don't know if that's ironic or weird or something, but I like .NET. And .NET Core, Prometheus exporter, sure. Something that maybe people don't think of when they think of Kubernetes or the CNCF landscape. It exists. Java has Prometheus exporters. Ruby, I'm sure, does. Every major platform and language has a way to expose metrics for your custom application so that you can scrape and query those out of Prometheus. Additionally, there's just an enormous number of applications that monitor anything, MySQL, Postgres, Nginx, Envoy itself has native Prometheus support. A lot of these bigger applications that are like CNCF Envoy is a Rev proxy, a popular one that's been popular, I guess, the last couple of years. But anyways, that guy has native Prometheus support. So Prometheus is just extremely widely supported and very easy to find integrations with for anything you want to watch. Another great reason to kind of use it. Prometheus is, yeah, like I said, one of my absolute favorite applications. It does exactly what it's supposed to do, and it does it amazingly. The final thing I'll just talk about with Prometheus is just that it is purposefully a single binary and not horizontally scalable. This has been kind of solved in 2 different ways. If you've heard of Thanos or Cortex, these are both different projects that are designed to take the Prometheus query to be Prometheus compatible and to hold long-term metrics and be horizontally scalable. We support both Prometheus or Cortex and Thanos and use them extensively at Grafana. I feel like I'm kind of close to time. I would be glad to show some tracing maybe if we want, but why don't we kind of wrap things up a little bit? If people have questions or thoughts, I would also absolutely love to hear what people are doing in the observability space. I don't what vendors you're using, what tools you're using, any of that. If anybody can share that, that would be great.
I actually got a quick question real quick. So I know so we use Prometheus quite a bit, and I use the alert manager within Prometheus to fire alerts like the Slack and stuff. When would you use Grafana to fire alerts versus alert manager? And what are some pros and cons from your perspective, since you've talked about both, Prometheus and Grafana, like when one is better than the other or when to mix and match?
We never use Grafana for alerts. So Grafana is nice and has a really clean, pretty UI, certainly way better than Alert Manager. But we believe strongly that your alert should be as close to your metrics as possible. So we do all of our alerting off Alert Manager as well. It is a little bit more annoying, or not as pretty, not as easy. And some people really like doing alerts out of Grafana, and so it supports that. If you are just getting started, you can use Grafana alerts. In fact, at my previous job, all of my alerts were driven from Grafana alerts, and it was fine. But our recommendation as a company is to always put your alerts as close to your metrics as possible, and we always use Alert Manager as well. And Alert Manager, for those that don't know, is a part of the Prometheus ecosystem and is directly tied to Prometheus. It queries it directly to generate alerts, and it also supports PagerDuty and Slack and a lot of these things. But yeah, do you guys, use Prometheus. What else do you guys use for, say, logs, or do you use tracing or anything else?
So, I mean, we use Elasticsearch. I hadn't really heard of Loki, so that's actually one thing that I'm now very interested in, and I'm going to look into. So I guess tying off of Loki, one thing I was curious about is Loki, it looked like you were able to tie in the Docker logs from Kubernetes directly very easily. And that's like one of the biggest things like we'd always like to see is those, log stack traces from Docker itself, or, the various containers that are running. And it sounds like Loki can do that like automatically from the searching within the Kubernetes cluster, similar to Prometheus to pull that out.
Right, so there's a lot of standard like Loki configs, or PromTail configs, I guess, more specifically. And it works the same way FluentD does, where it just tails the endpoint or just tails a log, just watches a file. And so it's very easy to point that at your Docker logs, we use it to actually watch most of the logs in var logs. So like the syslog and the audit log and some other Linux logs we watch as well through Loki. So yeah, you can easily keep an eye on all that. Cool. Yeah, Elasticsearch is great too. A lot of people just need something that's less fully featured and costs much less to run and operate, which is why we made Loki. But Elasticsearch absolutely has its place. Nobody at Grafana is saying Elasticsearch is bad or anything like that.
I know with one of our clients, we're definitely using Prometheus. That's generally what I try to stick to from that perspective, unless they're using something inside the managed services. So with AWS, it's CloudWatch, Cloud Alert, things like that. Jason, what are you guys using for your clusters?
So we use, for OpenShift, we do expose Prometheus, and we allow people to query Prometheus out of there and use that. But by and large, most of our organization is using VMware Log Insight after we ship the logs out to actually go and do searches and queries on the logs. They used to use Splunk, but Splunk's expensive. So
I think that's everyone. Yeah.
I was watching this. I thought these tools look really similar to BeRealize Log Insight in a way. Like I don't know. It's just the GUI that kind of reminds me of.
Yeah, I think. I agree with you, and I think we used it because obviously a big shop like UPS has VMware, and so we get all the tools that go with it. I think we've kind of we've adapted it to do application logging. I don't know that it was designed to be very good at it, so we've kind of made it work. That's the way a lot of organizations do. But we do have some teams that are more skilled than others that are actually querying, using Prometheus directly. In fact, I've seen some pretty Grafana dashboards built by some teams that are kind of off in the corner doing their own thing. So
that is my experience as well. We set up a Prometheus Grafana stack, and like I said, in my previous place, and some of the development teams loved it and were publishing custom metrics instantly and building dashboards and could see everything about their applications, and some just never understood it or didn't care or whatever. And it really felt strange to me because it felt so powerful to me to be able to build and understand and see so much information about your application. And I don't know if it just hits people differently or what, but yeah, we definitely saw a range.
Exactly what we have. It's exactly what we have.
The biggest problem I felt with my developers was explaining the concept of push versus pull. when it comes down to Prometheus. And like, they're like, what, I can't just push something to? And so then we went down the whole with the push gateway and like, is this more feasible? And, you know, especially how some of the Python, you know, applications, which are not, you know, as, you know, prone to being able to scrape metrics from. So it, especially when they're multi-threaded. So it was definitely a learning curve for some of our developers to get on the bandwagon for Prometheus with how the model is, you know, set up.
Yeah, we use the push gateway too. We only use it for short-lived applications though. Anything that's just kind of hanging out, anything that's permanent or whatever, anything that lasts more than a couple minutes, definitely we expose Prometheus metrics to be scraped. I feel like, and this is different per organization, but I feel like if you can build out that like custom set of libraries, like an HTTP client, and the HTTP client's already immediately instrumented, or an HTTP server, and the server's instrumented, and it's like a thin wrapper around your net core server or your Java server or whatever you're actually using. That's really what I think drives adoption, because then they can't help it. They just use the same server everybody else is using, and suddenly they have metrics. And then once they start seeing that, then I think they invest more in it.
I think the big thing that I like about Grafana is that you can create dashboards and then export them and share them with other instances of Grafana. So that's a big proponent of just being able to, if you have one team who's really good at it, and you can export that and share it with other teams that are interested in those same types of metrics.
Yep.
I guess one question I was going to have is with, you know, monitoring and all that, you know, it always comes up, you know, by default, at least for us, security conscious and aware. By default, Prometheus is all, you know, it's HTTP, not HTTPS. So a lot of stuff that we've found is we've had to put, you know, Nginx, you know, a lot of the endpoints behind a proxy in order to facilitate that. Or what we've done is put like within the Nginx const, a username password, just a quick token, so that, you know, in Prometheus scraper using the basic auth in order to help protect that a little bit. I'm curious what others are doing to help protect like Prometheus or Loki or other endpoints, you know, that might be scraping or being used to access, you know, for those endpoints.
So a lot of people kind of subscribe to the model that if it's internal to your cluster, you don't have to care. So that's probably the 99%, I mean, not that much, but the 90% case. It's all plain text, you know, all HTTP internally. But Prometheus, you kind of hit on what most people end up doing. It supports cert-based auth, basic auth, and bearer token auth, I believe, on the scrape jobs. So any of those that your application can support, and I'm sure it supports HTTPS as well. Of course, when you get into that world, then you have to manage certs. You can, of course, hit the old Boolean value, don't care if the cert is signed or not. And that's just a matter of company policy, like how far down the rabbit hole are you required to go to meet the security standards of your company. Larger companies, I'm sure like UPS, have far more policy surrounding that than smaller. That's normal. But Prometheus, I think, does a good job of supporting it as long as you're willing to, or able to kind of, I guess the part of the problem is you have to build the infrastructure around it, the operations around it to make sure you're rotating and doing all that. Prometheus has also, let's see, the black box exporter. So to help with this, certs are important, of course. The black box exporter can query HTTPS endpoints and provide information about certs, like for instance, the expiration date, which is what we all care about, so we don't have an outage because we let a cert expire. And then I wrote this guy here, cert exporter, which will do the same thing for on-disk certs. So this will take on-disk certificates and it will publish the expiration date so you can build nice dashboards and see them. It also works with, what is that thing called? The cert manager for Kubernetes, where you can, Kubernetes cert manager, right? Where you can build certs. So it'll look at the
They keep those names pretty easy, right?
Right. Well, this is cert exporter. It's cleverly named.
So it's not like AWS services.
Right. So if you use Cert Manager, you can watch certs with this as well, which will, yeah, you can see like when things are going to expire, make sure your rotations are not going to be too late.
Can you drop that link in the chat channel real quick? That looks like an awesome exporter that I'm trying to take a note of.
Sure.
I just searched it and actually bookmarked that too.
Yeah, I've scraped the ones from the Zoom chat and I posted them into the meetup. So.
Anybody who's been in especially enterprise software development for a long time has sat through multiple outages due to expired certificates. And in fact, I don't know if there's ever been a time where certificates have been perfectly rotated where you didn't have something go down.
Right.
Hey, so I used to work with Jason, and so he knows I think we had Jenkins jobs that just kept reminding us.
Absolutely.
But, yeah.
Same for user accounts. If they were going to, ADX accounts were going to expire or something, we
Password
had
changes.
jobs, horrible, bastardized Jenkins jobs that did all of our work for us. This was way back in the day.
Oh man, yeah, it has been a while now. Does anybody else have any questions around Loki, Prometheus, Grafana? If not, we can we can talk more about Joe's passion.
If people have time, I can kind of briefly show you some of this. I think tracing is maybe a little bit less well understood. Sorry, let me pause for a second. If you have questions.
No, I've got time. If
Actually,
others got time.
one last question.
Yeah.
So a couple of weeks ago, one of my sources had let me know that there's a potential 0-day for Grafana that's being exploited to exfil data, and I can't find any CVEs on it for anything recent. So I'm curious if you know of anything that is about to be released or not.
I don't know.
And we can go off recording if you want, but
off camera over here to see if just bring this right over here. I have not heard anything about this.
Yeah, it was a couple weeks. It was like a week or a week and a half ago, and I don't know if it was which version specifically, but I know we're not running the latest, but one of the guys, that I work with, he got a tip off from someone else and was like, "Hey, heads up!" And I know we use Grafana. Keep an eye on it. And I was like, oh, okay. And I started searching the CVEs, and I was like, I can't find any recently for Grafana, so I don't know if there's one out or not.
You always want to update your software.
People are discussing, let's see, this was today, this Alpine image apparently solves a image or some kind of vulnerability in 3.10, this 3.11 image. So the latest, they've already merged it. So, this is February 4th. That can't be right. Oh, opened on February 4th. Merged. When?
30th? 29th April.
Yeah. I don't know. I'll be honest, I haven't heard anything, but if you share an email or something, I would be glad to ask around and look a little bit harder and share anything I can find with you.
All right, yeah, I'll send you a link.
Sure.
Yeah, Joe, if you don't mind, I can share your email address with Brian via Meetup.
Sure, that works.
Okay.
Cool.
I mean, email addresses are nothing nowadays.
Yeah. I mean, I don't care. If you search Joe Elliott Grafana, you'll find this email address in about 3 seconds. So I do not care if anyone is, it is my public work email address. People do contact me on it to just chat Grafana, so I don't mind sharing it. Yeah.
I always ask. We have a large presence in the UK, so they're always talking about GDPR.
Sure. This is the extremely difficult to figure out joe.elliott@grafana.com.
There you go.
So there's not a whole lot to show with tracing. I love tracing just because of how much vision it gives us. It doesn't have as nice maybe visualizations or dashboards. I did show kind of the cool Loki integration earlier. I mean, Grafana itself has a nice integration, but this is Jaeger. I think Jaeger is an extremely neat application. I try to find time to contribute to it as much as possible. I work with the guys a fair amount. So these are different applications. See Cortex here. Cortex is our Prometheus long-term storage application. Here's Loki. Metric Tank is our graphite long-term storage. So I could, for instance, look at the Loki query front end, Let's look for specifically a query range query. See if we can find anything interesting. So this is kind of showing me some things that have happened recently in the last few seconds. Can find a big one. So Cyril, one of the Loki maintainers, has fun trying to get the biggest traces he can, and he's hit 100,000 spans before. It'd be fun to find one. But let's just do something sane like this. So this has got 902 spans. A span is a kind of, you can kind of think of it like a call stack in an application, because this is going to descend down through our microservice or distributed application. And so this gateway calls this other gateway function, and then that is now crossing a process boundary into what we call the query front end. And the query front end is going to distribute across a whole lot of, let's do this, queryers. So this is where we were talking about, I mentioned like 60 gigs a second, I think, is our record. The reason is because when you make a query to Loki, it shards it across as many different queries as possible. So this particular query took 300 milliseconds, and it sharded, I don't know, it looks like maybe 10 times. So it went out to 10 different processes. They all were grabbing logs and trying to do the same query and then kind of re-aggregating them at the end. I can probably find some information. These are stats about this particular query. Is there going to be anything interesting here? 600 bytes processed and 600 megabytes in 300 milliseconds. That's not too bad. And so it scanned that much data to return the information. So what's interesting here is just a well-instrumented application, and that's kind of the trick, is kind of investing in your instrumentation can give you insane levels of details about exact queries. Depending on your application, this may or may not be useful. We find it extremely useful because we're not so interested in the write path. Like we take 100,000 something, tens of thousands of requests per second on the write path, and they are extremely similar. The read path, though, depending on what exactly you query, can be broken apart in all kinds of different ways and is extremely complex. And so instrumenting our write path with tracing has allowed us to really understand how a query is distributed across our microservices and what's slow and what's fast. And if you have the time and money to invest in this, it does take some. I cannot recommend it enough. It gives you insane level of detail about exactly how your queries are being executed. Yeah, this is Jaeger. Jaeger is my favorite. But Zipkin is also a very popular open source application to do tracing. And then like everything, there's commercial vendors. I think most of the major observability commercial vendors have tracing options like Datadog and those guys. But yeah, cool. Well, I appreciate you guys coming. I mean, it's been a little over an hour. Thank you so much for listening. James, thanks for having me. I would love to do this again. I'll try to come up with something else interesting to talk about. Everybody who sat through this, for sure, thank you. I put my email up there. Feel free to contact me about anything observability or whatever. I'd be glad to chat. I love the local Louisville tech community. I've been here for 30-something years. I grew up here. I love this city. So,
well, Joe, I also run the AWS meetup. So if you have any AWS content, I'm sure those guys would be interested to hear from you as well.
It's been over a year since I've done AWS work, or maybe close to that. But maybe I need an AWS account again, a free account.
Oh, well, I'm also an ambassador, so I might be able to help you out with that.
Cool.
We also run DevOps NYC, so anytime I need speakers, I'll make sure to put you on my my list to go through the rotation. Yeah, man, definitely get a hold of me. I'd be glad to talk observability for sure. It is definitely very cool. All right. Do we have anybody have any questions, last minute questions for Joe? If not, we can wrap that up. All right. Well, thanks again, Joe. And I need you to send me your address because I have a gift that I give out to all of my speakers. Oh, cool. Thanks, James. And appreciation for you taking your time. I know it's not easy putting together demos and walking through it and making sure everything works, but I think you did a real good job not giving us a death by PowerPoint and actually giving us a practical demo. So thanks again for that. Cool. No problem. Thanks, everyone. We're set up. I think our next one is set for July 2nd. But again, these are virtual and we don't have I don't know if anyone's going to be taking off anytime soon to go anywhere. I'm looking at a calendar right here. So I think we can keep it at July 2nd, but if I'll put the post out there and ask if we need to move it to the 9th. But I think with being virtual and with our current situation still around lockdowns and everything, this is going to be virtual for a little while longer. But yeah, so I look forward to talking to everybody again July 2nd. And if you have any questions, or if you have any, desire to speak, go ahead and send me a note. With that, I'll wrap up. Thanks again, everyone. Have a nice night.
Cool. Thank you all.
Bye.